Yay, hashes! They're not as yummy as hash browns, but they'll do. Next, we have direct addressing tables. The elements in these have keys and values. We store keys in an array where they point to the different places in memory where the values are. In order to do this, we need to know the possible keys starting off. Since we need to know all the possible keys up front, we want to make a reasonable range. Like we don't want 10,000 spaces if we only have 8 elements. This is where hashes come in. Hashes help us store things in smaller spaces. You send your data through the hash, and the hash sends them into specific locations that the table points to. For example, the hash could be value mod 9. I should note that these elements are not in the hash table. This table simply points to the element's location. A problem can occur if there are multiple elements that end up in the same place on the hash table. This is called a hash collision. Another method is using a double hashing. In this method, you run a second hash on top of the first, and then put the element back into the table where the second one indicates. When searching for an element, if you don't find it at first, you just run the second hash, and then check there. You can also have each location in the table point to the linked list that holds locations that have multiple elements.